Hi, my name is Manisha Mishra. I am an assistant professor in Applied SEM Department Mathematics at Central Indian Institute of Technology and Management, Gurgaon. Today, I will discuss with you harmonic function, finding harmonic conjugate, elementary analytic functions, exponential. These are four topics, so I will discuss these topics with you. So first one is your what is harmonic function. So what is harmonic function? Any function which satisfies the Laplace equation is known as harmonic function. So what is Laplace equation? Del 2u upon del x2 plus del 2u upon del y2 is equal to 0. So first we know that our function, if fz is equal to u plus iota v, is an analytic function. This is your analytic function, as we all have already discussed in your previous lecture. So fz is equal to u plus iota v. F is a function of z and z is a function of x and y, so u and v also the function of x and y. So then u and v are both harmonic function if this condition is satisfied. This is your final condition. uh, Del 2u upon del x2 plus del 2v upon del 2u upon del y2 is equal to 0, and del 2v upon del x2 plus del 2v upon del y2 is equal to 0. If this condition is satisfied, then we can say u and v both are harmonic function. Therefore u and v are harmonic function. Now next one is your harmonic conjugate. So what is harmonic conjugate? Conjugate means u and v both are conjugate to each other. Such functions u v are called conjugate harmonic function if u plus iota v is also analytic function. So what is analytic function? I told you that if function is differentiable or if function is satisfied Cauchy-Riemann equation, then we can say the whole function will be your analytic function. So this is the definition of analytic. Now if u plus iota v means fz. If fz is your analytic function, then we can say u and v are the conjugate to each other. So there is an example here. So let's see the example. Find the harmonic conjugate function of the function uxy is equal to 2x 1 minus 5. So as I told you that u and v both are the function of x and y. So if let v be the harmonic conjugate of u, let v be the harmonic conjugate of u, then dv is equal to del v upon del x into dx plus del v upon del y into dy. This is the chain rule, so we can apply here chain rule. So dv is equal to, first differentiation is going partially with respect to x into dx plus second with respect to y into dy, because v is a function of x and y, so we can write v as derivative, as in derivative form. Now we need to calculate, we need to calculate our partial derivative. So first one is your first thing, we know that del u by del x is equal to del v upon del y. Del u upon del y is equal to minus del v upon del x. And what are these equations? These are Cauchy-Riemann equation. So del u by del x is equal to del v upon del y. That it means we can write here, sorry, we can write here del v upon del y as del u by del x in this equation. In this equation, we can write del v upon del x is equal to del u upon del y, and del v upon del y is equal to del u by del x. So just find our partial derivative. Del u by del x, del u upon del y. So dv is equal to, the new equation dv is equal to minus del u upon del y dx plus del u upon del x into dy. So just we need to find out partial derivative with respect to x, partial derivative of u with respect to y. So del u by del x is equal to, x is differentiating with partially with respect to x. So x differentiation is 1. So only 2, 1 minus y will be here. Where y will treat like a constant, because in partial derivative other variable always treats like a constant. Now differentiate u partially with respect to y. So del u upon del y is equal to minus 2x, because 2x, x is a constant, so write as it is. 2 is a constant, write as it is. One differentiation will be 0 because this is a constant, and minus y differentiation is minus 1. So del u upon del y is equal to minus 2x. Just put all these value in this above equation. So dv is equal to minus of minus 2x dx plus 2 minus 2y dy. So you have dv is equal to 2x dx plus 2 dy minus 2y dy. Just x dx 2 dy minus 2y dy. So we will get our v if we integrate, just integrate on both sides. So just on integrating both sides, so dv integration plus 2x dx plus 2 dy minus 2y dy, and plus this is your integrating constant. So dv integration is v, x integration x square by 2, y dy integration 2y, and y here y integration y square by 2 plus c. So this is your v, and this function is harmonic conjugate of u, is harmonic conjugate of u uh, with respect to v. There are lots of example here. This is your exercise, and this is the answer of this of your question, and next page is your exercise. So just do it yourself. What is, how we will calculate our harmonic function? First question is, prove that u is equal to, this is harmonic, u is equal to 2x 1 minus y, as I had already discussed this question with you. U is equal to this one, this one. So just prove all of these questions that these are harmonic or not. Now, there is another part is here. Find the imaginary part of the analytic function whose real part is given. This type of question always will ask in your final semester exam. So prepare this question, how we will solve these types of questions. So real part is given. Real part, that means u is given. Real part in fz, there one part is real, another part is an imaginary part. And which one is real? The u is real, iota part is always an imaginary part, so v is your imaginary part. So u is given, so we have u is equal to this one. Now we need to find out imaginary part, that means we are just finding v. So we will use Cauchy-Riemann equation to find our imaginary part. So Cauchy-Riemann equation, we need to find out our all partial derivatives. So if u is given, then just find del u by del x and del u upon del y, because partial derivative del u by del x, del u upon del y, del v upon del x, and del v upon del y. We have all only u is here, so just find del u by del x and del u upon del y. So u is differentiating partially with respect to x. So x cube differentiation 3x square minus 3y square, as it is x differentiation is 1, 3x square differentiation is 6x, and minus 3y square differentiation 0, because there is no x here. So y will always treat like a constant, and constant differentiation is 0. Now next one, del u upon del y. So del u upon del y means u is differentiating partially with respect to y. So x cube is a constant, so 0, minus 3x y square, so minus 3x is a constant, y square differentiation 2y. So 2y means 6 minus 6xy, 3x square differentiation 0, minus 3y square differentiation 6y. So now we know that this equation already used in above example. So dv is equal to del v upon del x dx plus del v upon del y dy. So just put all these value here. Minus del u upon del y, that means by using CR equation, we can write this equation as this equation. So we know that del u upon del y and del u upon del x. So v is equal to, just look at here, this line, dv is equal to del u by del x value and del u upon del u by del x value and del u upon del y value. Now just integrating on both sides. So dv integration is v, and 6y integration is going with respect to x. So x integration will be your x square by 2, so 3x square y, plus here x in dx integration x, and minus y cube minus y squared integration minus y cube upon 3. So 3 cancelled out. So this is your v. That means we have our real part, so we can find out our imaginary part by using another part. So this is your final answer. we have lots of question of this one. I will send you an exercise to solve all these questions. But further, uh, we will discuss our next topic, elementary analytic function. So what is elementary analytic function? Exponential form, in trigonometric form, and in logarithmic form. So first form is exponential form. So what is exponential form? We know exponential means base e form. So let z is equal to x plus iota y be a complex number and define the complex exponential. It means e to the power z form. Complex number, we have our complex number z. So exponential form will be your e to the power z type form hoga. So fz is equal to e to the power z is your exponential function. And now we know that e to the power z is equal to, so z is equal to x plus iota y. So just write here x plus iota y. Now base are equal, then power can be separated. So fz is equal to e to the power z is equal to e to the power x dot e to the power iy. Now e to the power x as it is. Now, next line, e to the power iy. We know that by De Moivre's theorem. What is De Moivre's theorem? E to the power I theta is equal to cos theta plus I sin theta. So here y is replacing by theta. So e to the power iy is equal to cos y plus I sin y. So just put this value in equation 1. So fz is equal to e to the power z is equal to e to the power x dot this value. So just multiply by e to the power x inside the bracket. Then you will get next one, fz is equal to u plus iota v. We know that this function, what is the value of this function? U plus iota v. So just put here u plus iota v e to the power x cos y plus I e to the power x sin y. On comparing both sides, then you will get your u and v in the exponential form. So this is your u and v. So it is easy to check that the CR equation are satisfied. So we know that our CR equation del u upon del x is equal to del v upon del y. Del u upon del y is equal to minus del v upon del x. This is our CR equation. So now let's check this is equal or not. This u and v are satisfying our CR equation or not. So just find out del u by del x from here, del u by del y from here, and del v upon del x and del v upon del y, and put in CR equation. So this is your del u by del x, del u by del x, del v upon del x, del v upon del y, and del u upon del y. So check, del u by del x is equal to del v upon del y. E to the power x cos y is equal to e to the power x cos y. That means u is satisfying our, u and v both are satisfying our CR equation. So hence CR equation is satisfied. It means e to the power z is an analytic function. So this is all the procedure of that. We are just proving this e to the power z, proving that the e to the power z is an analytic function. That means our exponential function is an analytic function. Now next form is your complex trigonometric function. As trigonometric means sine, cos, jet, cosec, sec, all 6 function will be here. So trigonometrics, for trigonometric function, first one, let z is equal to x plus iota y be a complex number. So we know that sin z, cos z, x sin x, sin a plus b formula, cos a plus b formula, but all these formula will be in complex form. So remember these 5 6 to 7 formula. So first one is your sin z is equal to e to the power iz minus e to the power minus iz upon 2y. Second formula is your e to the power iz plus e to the power minus iz upon 2. In trigonometry, we have already known this formula, e to the power I theta, e to the power minus I theta, but in complex number theta will be replaced by z, and z is equal to x plus iota y. So remember all these formula, learn, एक्चुअली इन सारे फॉर्मूलों को आप लोग लर्न करिए. सो साइन ए प्लस आयोटा बी या एक्स प्लस आयोटा वाई इज इक्वल टू साइन एक्स कॉस हाइपरबोलिक वाई प्लस आई कॉस एक्स साइन हाइपरबोलिक वाई. Cos x plus iota y is equal to this one, sin hyperbolic z. Here in first formula, hyperbolic is not here, so it will be e to the power I z. But in hyperbolic formula, iota will be removed. So e to the power z minus e to the power minus z upon 2y, and cos hyperbolic z e to the power z plus e to the power minus z upon 2. So next one, sine. Very important. Sine hyperbolic Iz is equal to, you can write I sine Z. If suppose iota part is not given and hyperbolic Iz type is given, then you can write I sine Z. Cos hyperbolic Iz means cos Z. And cos square Z plus sin square Z is equal to 1. Now, we will prove these formula by using z is equal to x plus iota y and also above formula. So first one, just 2.5 marks question always asked, that proof sin square z plus cos square z is equal to 1, cos 2z is equal to 2 cos square z minus 1. So just how we will prove all these formula by using complex number. So just take there is an example here, so let's see this example. Cos is proof that cos square z plus sin square z is equal to 1. So there is no nothing is in right hand side, so we will take our left hand side. So left hand side is cos square z plus sin square z. So we know that above formula, so cos z is equal to e to the power I z plus e to the power minus I z upon 2. Sin z is equal to e to the power I z minus e to the power minus z upon 2y. So just put cos z sin z value in your equation first. So e to the power iz plus e to the power minus iz whole square upon 2 plus e to the power iz minus e to the power minus iz upon 2y whole square. So we know that a plus b whole square formula, a minus b whole square formula. So what is your a plus b whole square? A square. So a is your a to the power minus iz, and b is your e to the power minus iz. So a square plus b square plus 2ab plus a square plus b square minus 2ab, and 2 square 4 is here, and 2i square 4i square is here. So 1 by 4 is common, so taking outside. Now power to power multiplication. So e to the power 2iz plus e to the power minus 2iz and plus 2 base are equal, then power can be subtracted. So iz minus iz, it will be 0. So e to the power 0, so 1. I square value is minus 1. So this is also just to solve this line. So 1 by 4 is outside. This value and minus this value will be cancelled out. Only 2 plus 2 is remaining. So 2 plus 2, 4. 4 by 4 is 1. So cos squared z plus sin squared z is equal to 1. So we can use our 6 formula and we can prove all these formula, that sin 2z is equal to 2 sin into cos z. So just sin 2z, we know that sin z e to the power iz minus e to the power minus iz upon 2i. So just sin 2z is equal to, use, if here z is here and here angle is 2z, so z is replaced by 2z. So e to the power 2iz minus e to the power minus 2iz upon 2y. So e to the power 2iz, we can write it e to the power iz whole square, because power to power multiplication, and minus e to the power minus iz whole square upon 2y. Now by using a square minus b square is equal to a minus b, a plus b. So just a square minus b square, that means a plus b, a minus b. A is your e to the power iz plus e to the power minus iz, e to the power iz minus e to the power minus iz. So a plus b, a minus b, we have already write this. Now sin 2z is equal to dividing and multiplying by 2. So just divide and multiply by 2, then you will get your sin z formula and cos z formula. So we know that sin z is equal to this one and cos z is equal to this one. So just we have already proved our question. Sin 2z is equal to 2 sin z into cos z. Hence proved. So next topic is your complex logarithmic, and this topic I will discuss in your next video lecture. And I hope this these harmonic topic, harmonic conjugate topic, and exponential and elementary analytic function. So these topic you will learn properly, and there is an exercise. I will send exercise tomorrow. So thank you.